3. So this is the question. And of course, when we want to use L'Hopital's rule for indeterminate forms, we can say that it's infinity over infinity, or we can say that it's 0 over 0. And then only in these cases would it help to use L'Hopital's rule. And by L'Hopital's rule, I mean to take the derivative of the top and take the derivative of the bottom, and then sort of take the limit again and use substitution to see if you get a valid answer. But what you'll notice is that this isn't infinity over infinity or 0 over 0. It's 1 over 0 from the right minus 1 over e to the 0 minus 1. So this comes about to being 1 over 0 minus 1 over 1 minus 1, which is 1 over 0 minus 1 over 0. And the thing is that since we're coming from the right, we're approaching 0 from the right. And if we approach 0 from the right, we shoot off to infinity. So this would be infinity. It would be infinity minus infinity. Now, that's actually not one of the applicable forms that we can use for L'Hopital's rule. So instead, we're going to put it in a form that is sort of convenient for us. And by that, I mean to sort of combine this fraction. So we're going to take the limit as x approaches 0 from the right. So we're going to combine the top and the bottom. So I'll have x times e to the x minus 1. The way that I usually do this is I multiply the bottom and I put that in the denominator. And then I multiply the top. I sort of cross multiply here. So I'll have e to the x minus 1 minus x. And then I'll evaluate if I have one of these forms, infinity over infinity, or if I have 0 over 0. And before I do that, just so it's a little more clear to me what's going on, I'm going to actually simplify the denominator. So I'm going to say that this is actually the limit as x approaches 0 from the right of e to the x minus 1 minus x over. So I'm gonna sort of distribute here. So I'm gonna distribute to e to the x. I'm also going to distribute to -1. So I'm going to say this is x times e to the x, and then I'm going to distribute to -1 as well. I'll say that's negative x. And then let me try substituting. And if I substitute and I get, these forms, then I'll take the derivative of the top and the derivative of the bottom, and then I'll try substituting again and see where that gets me. So I would have e to the 0 minus 1 minus 0, and I will have 0 times e to the 0 minus 0. Remember that if you have a to 0, it's equal to 1. So anything to the 0 power is equal to 1, which means this is 1, right? So it's 1 minus 1 minus 0 over 0 times 1 minus 0, which is 0 over 0. So, this is definitely a candidate to use L'Hopital's rule on. So basically, just so that it's clear what we're trying to achieve here, I essentially want to take the derivative d over dx of e to the x minus 1 minus x. In other words, I want to take the derivative of the top, and I want to take the derivative d over dx of x e to the x minus x. So I want to take the derivative of the bottom as well. I'm going to sort of do these on the side and then come back and then put everything together, just so I don't sort of like clutter my fraction here. So if I take the derivative of the first guy, or the numerator as it were, I'll have e to the x, right, minus 0 minus 1. E to the x minus 0 is just e to the x, and then I had that minus 1 here, so that's minus 1. So this is my numerator, right? And then for my denominator, so I'll go ahead and take this guy and work on it here a bit. So I'll have d over dx over x e to the x minus x. Now, this is sort of like the sum and difference rule for derivatives, where if you have two functions being subtracted or added together, you can actually split the functions apart and then just combine them later. So I can take the derivative of this separate, and I can take the derivative of this separate. Now note that this isn't x plus e to the x minus x. In that case, I would take the derivative of this separate and the derivative of this separate and the derivative of this separate. This is x e to the x. So these are actually being multiplied. So I take the derivative of this together minus the derivative of this. So, and this is of course being multiplied, so I actually have to use the product rule here. So the product rule is you take the derivative of the first guy, which is just 1, you multiply by the derivative, or not that you don't multiply by the derivative, you just multiply by the second function, which is e to the x. So I took the derivative of the first, I kept the second the same, and then I add that to the derivative of the first, or not the derivative of the first, but the derivative of the second, which is e to the x, because the derivative of e to the x is just e to the x, and then I multiply by the first. So that is a manifestation of f prime g. So I take f prime, and then I multiply by g, and then I add that to g prime, which I did here, and then I multiply by f. So f prime g, g prime f. That's an easy way to remember it. So just to recap, I took the derivative of the first, kept the second the same, took the derivative of the second, kept the first the same. And then this is what I have as my derivative for the first half. And then the second half is -1, right? Because the derivative of x is -1. So my answer here is e to the x plus x, e to the x minus 1. I took the x and I put it in front of e to the x. So sort of long, but there's my derivative for the bottom nonetheless. So I'm going to come back here. I'm going to say this is the limit as x approaches 0 from the right. And I'm going to put my numerator on the top. I'm going to say this is e to the x minus 1 minus x over, and then I'm going to take e to the x plus x e to the x minus 1, put it on the bottom. So I'll have e to the x plus x e to the x minus 1. And now I'll try substituting again and see, if that gets me anywhere. So if I substitute, I'll have e to the 0 minus 1 minus 0 over e to the 0 plus x e to the 0 minus 1. So e to the 0 is 1, so that's 1 minus 1 minus 0, it's just nothing, right? And then I have 1 plus 1. So I want to put a 0 here as well. So I'll have 1 plus 0 minus 1. So that's again just 0 over 0. So it seems like I have to use L'Hopital's rule once again on this bottom piece here. So by that, I mean to take the derivative of the top. So I'll do d over dx of e to the x minus 1 minus x divided by, let's see here, e to the x minus 1 minus x. I don't think I want to, right, you know what, I think we sort of made a mistake here because the derivative for the top piece was actually just e to the x minus 1. So instead of putting e to the x minus 1 on the top, I should actually have e to the x minus 1 here. And then on the bottom, I have my derivative. But if I substitute, I'll get e to the 0 minus 1. And then we already know that we have 0 in the denominator. So it would just be 1 minus 1 over 0, which is 0 over 0. So I have to take the derivative of the top and the bottom once again. So if I take the derivative of the top, that's just e to the x. And then if I take the derivative of the bottom, I'll have e to the x plus, so now I have to find the derivative of x times e to the x, which I already did. So I already know that it's e to the x plus x e to the x minus 1. So it's plus e to the x plus x e to the x minus 1. And if I substitute now, I'll get e to the 0 over e to the 0 plus e to the 0 plus 0 e to the 0 minus 1, which is just 1 over 1 plus 1 plus 0, which is 1 over 2.